Okay, so I just go over, okay, to you on the operational amplifier. You understand, basically, you need to understand, okay, bipolar transistor, a diode, operational amplifier, okay, and the next transistor will be JFET. That's a very, very important for technician and also for engineer if you keep going up, okay? So basically I just go over here. Okay, let's see. Last time we already going to you on the amplifier operation. This is the amplifier you get a input at negative and an input at positive. That's what they say, inverting input, and that they call a non-inverting. Okay? So, and the one output. And basically, they need to power supply for the op amp to working. And the power supply will be plus or minus 8 volt up to plus or minus 38 volt. In the lab we're working on, we're using 15 volt, plus and minus 15 volt. Okay? And if you're looking into the schematic, the difference between the inverting and non-inverting input, they call a VD. That means differential voltage equal V at positive and minus V at negative. Okay? And in general, for ideal op amp, basically you cannot get ideal op amp anywhere. Okay? Open loop AOL, open loop gain, should be infinity. Input impedance, that means between the positive and the negative of the op amp, they want it to be infinity ohm. What that means? They don't want any current go into the op amp. And the output impedance, that means from the output you get a current either coming in or coming out. They want the output impedance to be zero. The thing that they want to get a more current. Okay? And this is very important here. The differential input VD on the time equal V in at positive minus V in at negative. They have to be equal zero. That will be telling you one thing. All the time, V at positive will be V at negative. That's a key point. Okay? And if you're looking here, this is the IC. You're working on the left volt, 741 op amp. Okay? This is a they give it to you the pin number. Okay, we don't care about that one. Okay. However, they're talking about practical op-amp. Okay. You can see the same thing. Okay. However, practical op-amp, high voltage gain, very high input impedance, very low output impedance, and they want a wide bandwidth. That means the bandwidth will be wider. Okay. Practical op-amp, output voltage Vout equal V at point T minus V at negative times the gain. Okay. That means the VD, the different voltage times the gain. VD difference between two inputs, the gain AOL, open loop gain, of 741 close to 200,000. That means open loop gain when you go to buy the 7441 op-amp without any connection, they get the gain is equal to 200,000. Okay. When the input applied to the is too high, okay, that forces the op-amp into the saturation. That will be telling you one thing. You're working on the op-amp, you're using the power supply, plus 15 volt and a minus 15 volt. Okay? So basically, they don't care what is the gain equal. However, if the output higher than 15 gain, 15 volt, and lower than minus 15 volt, the op-amp no longer get the gain anymore. They will be saturated. That means the output they can be equal maximum 15 volt or minimum minus 15 volt. Okay? So open loop gain, AOL, is define amplitude output amplification without any external feedback signal connect to it. And for typical operational amplifier is about 100 dB, decibel, okay, at 0 hertz frequency. 100 decibel almost equal to 200,000. And last time we already did this one, okay? So I'll make sure we can record it. You get the time. You can go through it. Now, if you're looking on the different op-amp showing here, this one is they get applied only one input, another routed. Okay. And now the other op-amp, they apply to the positive, negative routed. And this one, they apply both input at the positive and negative. And you can see the difference. When you apply both signal input, and they must be opposite. This going up, this have to be going down, 180 degrees out of phase. Okay, that is absolutely, you have to follow that. They say two signal voltage of the same phase, same frequency, same amplitude are applied to the input. When equal input signal are applied to the both input, they cancel out, resulting in a 0 volt output. That will be telling you one thing. when at the both input you get an identical signal that consider to be the noise. That means noise is the unwanted signal. The signal you don't want it. And the op amp able to cancel out. Okay. Input offset voltage. So basically, for the op amp, when you connect both input at negative and positive to the ground, or you tie together, that means identically both input connect to the ground and the output supposed to be zero. However, if it's not zero, like they can get a 1 millivolt or 10 millivolt, even input connect to the ground. That's what signal we call a offset voltage. They're supposed to be zero, but they're not. Okay? So when you do the left volt, you also deal with that. In order to do, so basically, they say you make the connection like that one. This is the external potentiometer adjust for zero output. So basically, you connect positive, negative input to the ground, and you're looking at the output, they're not zero. So if you connect the potentiometer here, okay, and you can adjust this one until they get zero. That means adjust for zero output. Okay. So adjust offset voltage connect the port to pin 1 and 5. Connect both input for the op amp to the ground. And see if you connect the meter, if they not zero, then you need to adjust this port. Make sure they get zero. Okay, open loop, close loop, op amp. Configuration. Okay, basically by the basic definition, gain equal V out divide V in. That's the voltage gain. If you get a power gain, that means a P equal P out divide P in. Okay? So now for this circuitry here, they connect output back to input. That's what they call a closed loop. Okay. Now on that one, make sure everyone try to understand. Okay. This is the gain 100 dB. Okay. We just try to say equivalent to 200,000. That's an open loop gain. Okay. That's what they call the gain A. And this side will be F. That means frequency domain. First thing is here, frequency 10 minus power minus 1 power 0. So at this point here, okay, if you're looking on the gain, you go to the left, 100 dB. If you want to see the frequency, you're going down. 10 minus 1, that means 10. 10 hertz. Okay? And when you go into that one, same thing. You want to see the gain go to the left. gain going down 80 dB, and the frequency going 10 to the power of 2, that means 100 Hz. Okay? Basically, the bandwidth from here to here. Okay? That is the bandwidth. That will be bring it up to you one thing. When you try to get a wider bandwidth here, then frequency will be going up. Okay? And the gain will be going down. Okay? For example, you go to this point. So you can see the gain going down to 20 dB and the frequency going up 10 to the power of 5. Oh, okay, that's a key point. Okay, make sure if you get the wider bandwidth, then the gain will be moving down. Okay, this is the first one. You have to pay attention. Make sure you can understand. When they connect this circuitry, okay, so this is the input here. Okay, they go to a negative input and a positive input connect to the ground. The negative input they call inverting op amp, inverting, and this will be non-inverting. Okay, and when they connect this way, the name will be inverting. Okay, inverting operation. You get two op amp very important. First one, inverting amplifier. The second one will be non-inverting. Okay, try to understand that. When you're looking into the schematic, the circuitry, you have to recognize, is it an inverting or is it a non-inverting or that will be a summing amplifier, okay, whatever. Okay, so for inverting, input applied to the negative and output positive will be rounded. Okay, and also make sure you know V different. Equal Vs positive minus Vs negative, and they want it to be 0. The thing is, difference between two inputs will be 0. Okay, that will be Vs positive equal Vs negative. Okay, so you can see Vs positive connect to the ground. That means 0 volt. So at this point, they will be also 0 volt. Okay, the thing is, Vs positive equal Vs negative. However, this 0 volt in here, okay, they say this is a virtual route. Okay. Now, this is route, and this also be route. The difference is 0 volt in here and 0 volt in here. But one they call a virtual route. And the other one you connect the wire to the route, they call a physical route. Physical route, that means you need a wire connected to the route. And a virtual route, without connect anything to the route, they 0 volt. Okay? So RF that they talking about, this resistor here. This resistor connect from the output to the input. That's what they call a feedback resistor. Okay? RF feedback resistor between output and inverting input to produce closed loop gain, ACL. No current flow into the input terminal, while high input impedance, closed loop gain, ACL equal minus RF divided to RE. Okay, that means you take the RF divided to RE, you get the gain. Okay, and you get a minus gain. Okay, so if you can see how they working, current I here. Okay, when they go up to the virtual route right here. Okay, when they go up here, they cannot going down. The thing is that the same voltage current cannot flow it. And the current cannot flow into V2 minus here. High input impedance. So the current now they have to be flow this way. Okay, when they flow it in, this side positive and this side will be negative. Okay, so if this right side of the RF negative, that will be telling you at the output of amp here must be negative. And if they negative on the V out, the other side of V out must be positive. Okay, so the current when they go through the RF, okay, they cannot going down. How? The thing is negative and the other's positive. Okay, you see that? You get negative here, positive here. So the current will be flow into the op amp. In this case, they call a sink current. Okay, that means the op amp will be pull the current into it. Okay, and now at the output, you can see you get a 1 positive here, negative here. So the current of the load, they have to go from positive to negative. So that's why IL. Load current. This side will be I. Okay? So everything, when you're looking into the amplifier, you recognize that will be inverting amplifier and how the current flowing. Okay? Now, you get apply 5 volt to the negative input. Okay? So basically, this will be inverting amplifier. So the first thing I can do, we can calculate the current I. Okay? Current I. You can see you get only 5 volt. Go to R1 and this side will be the ground. Okay? So that's why Ohm law, you can say 5 volt divide R1. That's how you get the current I. Okay? So current I, we already telling you in here, equal V in divide R1. In this case, equal 5 milliamp. Now, if you want to calculate the gain, closed loop gain, HCl equal minus RF over R1. So that will be 1.5K divide 1K minus 1.5. And now if you want to calculate the V out equal the gain times V in. That's what you get, minus 7.5. If you want to calculate the load current, IL, that means you take the V out divide R load, you can get 1.5 milliamp. No, and 1.5 milliamp. If you calculate the op-amp current, you adding current I and the IL. That given to you 6.5 milliamp. Okay? That's what I hope when you're looking into the inverting amplifier, you're able to calculate everything you need. Okay? Okay, any question? Okay, if it's not, you can see that. Last time we already calculate for you. So only thing is I just go through that quickly. For this circuitry, you will be see in the level. They want to calculate the gain. You can get F here, in here, minus F over I. If you want to calculate the V out, you take the V in times the gain. Okay? If you want to calculate the current I through R two, you take the voltage 1 volt divide to 1 kilo ohm. That's given to you. Okay? Current I. And the load current, that means you take the V out divide R5. And finally, if you want to calculate the op-amp current, you adding I and I load. Okay? And now you can see they will be applied the input 1.5 V peak to peak at the frequency 1 kilohertz to this inverting op-amp. First thing, closed loop gain minus R2 over R1. V out will be V in time the gain. You get minus 3.6 V peak to peak. Okay. The minus side will be telling you if the input positive, output negative. If the input negative, output positive. That means input output 180 degrees of phase. Okay. Note the input and the output is inverted 180 degrees of phase. Second one, non-inverting amplifier. Try to see what the difference. When you get the input, that's your input here. Apply to the positive input, that will be non-inverting operational amplifier. Okay. First thing, you have to know what the input to the positive, not this 5 volt. Input have to be right at the positive, that means at this point. Okay. So basically, at this point, you get 5 volt and you get R2, R3. Then you have to using the voltage divider to calculate the V here. I can say VA, for example. They will be equal 5 times R3 divide R1 plus R3. Okay. So 5 volt times 1K divide 1K plus 1K. So I believe at this point here, VA equal 2.5 volt. Correct? Five times 1 divide 2. Okay? 2.5 volt. So at this point, 2.5 volt. Okay, so the difference between positive and a negative 0. So that will be telling me at this point, you get 2.5 volt. Correct? Okay? And this is just a wire. So at this point, also 2.5 volt. Okay? Now, first thing they try to see the gain of the non-inverting. Okay, the gain of the non-inverting, they given to you here. ACL equal 1 plus RF divided to R1. Okay. And V out will be equal the gain times V in. In this case, V in equal VA, not equal V1. Okay? The V in have to be at the positive input of the op amp. Okay? And the current I out, okay, IL, you add them up, same thing, like non-inverting. Okay? And let's see, IL plug it in. AIL always greater than 1. You know that, right? The thing is 1 plus. So that's why all the time have to be greater than 1. Okay? And V out equal IL times RL. If you get the current, IL means load current, and you get the resistor, then you can calculate the voltage. Okay? Let's see, where I equal V in divide R1. Okay? I try to explain to you on this one. Okay? So if you calculate the V out, V out will be calculated from output to the ground. That means you can calculate the V out here. Take IL times RL. Also, you can calculate the V out on the other way. V out from here going to RF, go to ground. So V out can be equal I times RF plus R1 times RF. Okay? That's what they're telling you right here. Okay? That either way you can calculate the V out. Okay? So V out equal V in times the gain. The gain will be 1 plus RF over R1. Okay? And that finally, they given you the gain equal 1 plus RF divide to R1. So when you're looking into the circuitry, you're able to identify what the voltage at positive input, what the voltage at negative input here, okay? And what is the gain? The gain will be 1 plus RF divided to R1, okay? If you want to calculate the V out, you can calculate either way. If you get the load current and resistor, you can calculate the V out. Or if you get the I current, okay, and RF and R1 value, you also calculate the V out. Okay, so this is non-inverting amplifier. The thing is the input apply to positive. Okay. And RF, that means the feedback resistor. Okay. And you can get R2. So one thing you have to know, the voltage here, okay, VD. So the voltage at positive will be the same as V1. So V1 equal V in. Okay. Now let's see. Input V in connect to the non-inverting input of amp. Okay. The closed loop gain ACL equal 1 plus RF over R2. Okay. Where RF is feedback resistor, the input and the output is in phase. That will be telling you if you get a sine wave, input positive, output positive, input negative, output negative. Okay. For the above circuit, given RF 1K, R2 equal 1.5K, V in equal minus 2.5 volt DC. Shown for the gain. Okay. And you already know the gain, right? 1 blood, okay, IF over R2. Okay. And now they want to know the current I to R2. So basically, for this circuitry, they say V in might equal 2.5. Okay. So equal 2.5. So you get 2.5 here. Then also 2.5 here. The thing is the difference between two input is 0 volt. So current I will be equal 2.5 divided to R2. Okay. And the V out equal V in times the gain. And ACL here. Okay. That's a very simple calculation for either inverting or non-inverting. This one, I think last time we not done. Okay. For the first one, example, for circuit show, they want closed loop gain ACL. Okay. Telling me what the value you get. You do calculation. Okay. I given you the formula. 1 blood. Okay. RF over RL. Okay. And on this one, let's see, the gain time V in. Okay. And the current I through the 10K. That means they want current I here. That's very simple. Equal V in equal 2 volt. You get 2 volt here. Same thing. You get 2 volt here. So I equal 2 volt. Divide 10K. Okay? So basically that will be calculated for the first example here. Okay? And for the second example, that will be inverting. Amplifier. Okay? And you know the gain equal minus. Okay? I just given you formula here. ACL minus RF over R1. Okay? And if you want to calculate the I equal V in divide 2.2K. Okay? If you want to calculate the, let's see, determine value of RF, require to produce closed loop voltage gain of minus 100. Okay? They given ACL minus 100 and ACL equal minus RF over R1. Okay? So you want the value of RF. So RF equal, okay, minus ACL time time R1. Okay, you will get R1. You get the gain. You can calculate the RF. Next will be summing amplifier. Okay, and this is also unity gain amplifier. Unity gain, that means the gain equal 1. When you connect circuitry this way. Okay, let me know RF. That will be telling you input output the same. Okay, that's what they call unity gain. Okay, another name, they will be a buffer amplifier. Okay, or the isolation amplifier, or the follower. That means they get a different name. Okay, and the gain equal 1. Okay, that means input output will be the same. However, what the big difference between in and out? In 10 volt, 10 volt, output 10 volt. In 15 volt, output 15 volt. Identical, same thing. Why we need this amplifier? Who knows? In and out, the same thing.
Matching.
Well, can tell me, why do we need that amplifier? You apply 10 volt, you get 10 volt. You apply 15 volt, you get 15 volt. Why we need that? Okay, I telling you. That will be telling you one thing. The input to the op amp will be a high impedance. Okay? That only telling you they isolate between input and output. That is the difference. So that's why you can see in any power supply, in your computer, in any circuitry, electronics, they will be using the unity gain amplifier. You can see you're working on left volt. Okay. If they need amplify, that amplify have to go through the unity gain amplify. Why? The thing is, sometimes when you're working, some problem is you short the output to the route. Okay. If you connect directly into the power supply, that will be cook the circuitry. The thing is they get the isolation. That means even the output connect to the route, but the circuitry not burn out. Okay? Make sure you understand that. In any power supply, they have to get this isolation amplifier that protect for mistake if the output shorted to route and the power is still okay. Otherwise, they will be burned out. Okay? And they get a different name. They can be unity gain amplifier. They can be called a buffer amplifier, or the isolation amplifier, or they be follower. Okay? Make sure you get along with a different name. Okay? So any question regarding into the isolation amplifier. Okay, if it's not, we go into another one, summing amplifier. That's simple, okay? This is the inverting. However, before you apply only one input, now you apply V1 input, V2 input, V3 input, okay? And you want to calculate the output, and this is the formula. Minus V1 plus V2 plus V3, okay? That is, we call a summing amplifier. Okay, next one. Slew rate. Okay. The maximum rate of change of the output voltage in response to a step input voltage in the slew rate of an op-amp. The slew rate is depending on open, the high frequency response of the amplified state within op-amp. Basically, you see this circuitry here. This is the unity gate. Input output will be the same thing. Okay. That's why they given to you. This is the input from 0 go up to output here. Okay. However, the output is supposed to go this way. Go. No, they not. They take a little time from the input here go up here. We call it delta T. Okay. Step input voltage and resulting output voltage. Delta V out equal V at the positive minus to minus V maximum at the negative. The unit slew rate is a volt per microsecond. That's just telling you, okay, that takes how long output will be going up. Okay. That's what they call slew rate. And this one, they just given you one example how to calculate that the output voltage of the certain op-amp appear as so in the following. In response to the step input, determine the slew rate. Okay. The output goes from lower to the upper limit in 1 microsecond. The limits are taken at a 90% point as indicated. So the upper limit is 9 volt and the lower limit is minus 9 volt. Okay, so basically they calculate from here up to here, not a 10 to minus 10. Okay, the slew rate is del equal delta V out divide delta T. Okay, they will be 18 volt per microsecond. That means they take the difference between minus 9 and the plus 9. Total will be 18. Okay, and they divide, okay, 1 microsecond. So that's telling you the slew rate will be 18 volt per microsecond. Okay, so if you want to calculate the example related here, okay, they say go from 8 volt to 7 volt in 0.5 U second. What is the slew rate? That's easy, okay? They will be equal, okay? Let's see. 7, okay, volt. Let's see. You get 7 minus 8 volt, okay? And divide 0.75. Gain bandwidth product. An increase in closed loop gain causes a decrease in the bandwidth. We already know. If you want to get a high voltage gain and the bandwidth, okay, will be decrease the bandwidth. Unity gain bandwidth, ACL, time FC, okay, and they given you the example here. And also you get a solution. Determine the bandwidth of each of the amplifier. So both of them have an open loop gain of 100 decibel. Unity gain bandwidth 3 megahertz. Okay. For non-inverting. Okay. That means this is non-inverting. The closed loop gain ACL. Okay. 67.7. FC equal bandwidth. Okay. Unity gain bandwidth divide ACL. That means 3 megahertz. Okay. Right here. Divide to the gain. That given you 44.3 kilohertz. Okay. And for the non-inverting here, they also calculate for you. Okay. If you get the time, you try to do it. Or in case if we given a question to you, then I give you the formula to calculate it. Okay. Different data from lab volt. I just quickly go through for you. Differential amplifier. Okay. So a two input circuitry V1, V2 that amplify the difference between V1 and V2. V1 connect to inverting, V2 connect to non-inverting. When you see that one, that will be the name, differential amplifier. And when R1, R2, R4, R5, that means R1, R2, R4, R5 equal the different amplifier subtract V1 and V2. So Vout equal V2 minus V1. That's just the formula. Okay. In practice, input impedance for V1 equal ohmic value of R1. Input impedance for V2 equal ohmic value of R2 plus R4. The different amplified circuit can combine the gain effect from the inverting and non-inverting resistor ratio. Okay. Now, if you're looking on that one, if you want to calculate it, then you have to use what they call a superposition. What that means? First thing you want to calculate for input V1, then V2 have to be rounded. Okay, that means inverting. Then you get the gain equal minus R5 over R1, and you calculate the V out R1 for V1. That is the first calculation. The second thing, you have to calculate the V out 2 for input R2, V2. So first thing what you need to do, you need to calculate the volt right here, right at the input positive. You're using the voltage divider to take the V2 times R4 divide R2 plus R4. Then you get the voltage in here. Okay? And now the voltage at positive will be equal to the voltage at the negative. And this is the non-inverting. And the gain will be equal 1 plus R5 divided to R1. Okay? So that is you can calculate the VL2 and you add them up. That's why in here they already given to you. How do we calculate for V1? How do calculate the V2 out? Like I just talking to you. Okay? Now, in here they get a question. If V1 and V2 equal 6 volts, what we are supposed to be? A, B, C. Telling me which one? First thing,
C.
if you
I think it's C, sir.
you get C, right?
Yeah, C.
Perfect. Right, you know. First thing, you have to telling me VA. VA equal V2 times R4 divide R2 plus R4. If you calculate it, you can get 3 volts. Okay? So, if you see if V1 and V2 equal 6 volts, and VL equal, first thing, VL will be equal 0. They get both input the same. However, in here they can ask you VA. VA cannot equal 0. We already calculate they have to be 3 volts. So the answer, right answer will be C. See that? 0 volt and VA will be C. Okay? So, next, in this circuitry, the sine wave generator apply an unwanted common mode input voltage VCM. VCM means common mode. Okay. to both input. So basically, you see you get a sideway connect to either one or two. Okay. Due to the common mode rejection of E1, sideway does not appear at the out. Okay. Also, I can tell you, when both input of the op amp get identical signal, same voltage, same frequency, okay, same everything, that considered to be the noise, unwanted signal, and the op amp will be canceled out at the output. Like I already talked to you, if you connect both input op amp to the ground, output supposed to be zero. Okay? So, due to the common mode rejection E1, the sideway does not appear at the Vout. Common mode input voltage appears across the inverting or non-inverting input of a different amplifier. Across both input of a different amplifier. Which one, A or B? Common mode input voltage. I believe the answer will be B. They have to be on both input. Okay. Okay. Let's see. In this different amplified circuit, resistance R1, R2, R4, R5 are made equal due to the resistor value Vout equal V2 minus V1, or the difference between the input voltage. Okay. The output voltage polarity is determined by the relation between non-inverting input voltage V2 to the inverting input voltage V1. The V2 polarity dominates V1 polarity and determine the output voltage polarity. Okay. The following relation should apply. You will not saturate to the circuitry. V out equal V2 minus V1. VA, that means right here, voltage divider. Okay. VD, that means the difference between two inputs, they be zero. And VA equal 4. Okay. That means input impedance. In this circuitry, S1 is used to switch V2 or V1 into the circuit Vout. Vary between 0 is essentially 0 for either. Vary between 0 minus 10, both A and C, depending on position of S1. So basically, if they connect this way, two input will be the same, V2. If you go to V1, that will be the same for V1. Okay? And they want you to select either A or B or C or D. Okay? And they give it to you. The answer will be B, essentially 0 for either S1 position. That's for sure. If they are on this side, output, input to the op-amp will be the same V2. If they move to V1, they will be same V1. When the input will be identical the same, output supposed to be 0. Okay? So, the different amplifier combine input waveform and account for amplitude and the phase. If R1, R2, R4, R5 are equal value, that they just repeat it. Okay? When you're working on the level, you can see this again. Okay? Based on circuit information, Vout equal. Okay? That means you have to do the calculation like we already showed you. First thing you need to calculate the voltage right here. Okay? That means you take the V2 times 1K divide to 10K plus 1K. Okay? And now, first thing you have to working with the V1 out. So basically, if you work with the minus inverting input, then this side must be round. Okay? And the gain for the inverting will be minus 10 divide 10 minus 1K. Okay? You take a minus 1K, you times the V1, that you get a Vout1. Now, you want to calculate the Vout2. That will be telling you you need to calculate the voltage at positive. And this voltage will be the same on this voltage. Okay? So if you get this voltage here, you can calculate the current through 10K. And that current I here. Okay? Then you calculate the gain for Vout2 will be 1 plus RF divide R1 times V in here. Okay? So, based on the circuit information, Vout equal. So, if you calculate that, you're telling me A or B or C or D. That's the last thing I think will be asking you. Who get the answer, let me know.
C?
A or B or C or D.
Would it be B?
One answer D. Who else?
I got B too. B.
You say B. Who else?
I'll go with C.
Correct. The answer will be C. However, you're working on left zone. You enter A, they don't want. Enter B, they don't want. Enter C, they want. Okay? However, we're asking you to understand it if you're able to do it. Okay? See that? For phone peak to peak. Okay? V2, V1 are our phase. Therefore, input voltage will be added. Okay. The thing in Vout will be V2 out minus V1 out. Okay. And minus to the other minus mean added. Okay. So that will be done for this time. Okay. And make sure, okay, we don't have a let's see. Okay, any question, anything? If it's not, okay, I wish all of you get a very good long weekend, right? That take a week for spring break. And we'll be see you guys on April 7th. Okay?
Mr.
So,
Fan.
yeah.
Thank you, sir.
Okay.
Have a
Thank you, sir.
great
Good
spring break,
night,
sir.
everyone.
Thank
Okay?
you. Bye.
Bye.